So this is a question that several students have been asking about. So I figured I'd just do a video solution to it to show you guys how to do this particular problem. So it says a rectangle is inscribed with its base on the x-axis and its upper corners on the parabola y equals 3 minus x squared. What are the dimensions of such a rectangle with the greatest possible area? Since the area will be a cubic function, you should estimate the maximum by graphing the area function. Okay, so what's going on here? So what I did first, right below, you can see this, is I graphed that parabola, right? So that's 3 minus x squared. That's a graph of 3 minus x squared. So think of like fitting in different rectangles. So, I could have something like this. You might have something like this. Oops. And so on. And there's some rectangle for which you will have a maximum area. So somewhere in here, and I don't know exactly where it's going to be. I'll just draw it like this. There's going to be a rectangle that has a maximum area. Okay? So in general, we know that the base of that rectangle, like the width of that rectangle, since this distance here in general is going to be x, then that means this width from here to here will be 2x, right? So this will be 2x. And then the height here, since it's going to touch the function at that point, and we know the equation of that line, remember it's 3 minus x squared, that height y is equal to 3 minus x squared, right? It's got to be exactly that function. So this is going to be 3 minus x squared is going to be the particular height, right? Because that's what y equals. So for a particular x value, right, for this particular x value, whatever it may be, when I plug it in, I'm going to get that particular height, right, that y value there. So that means the area of that rectangle, so the area of the rectangle is going to be the width times the height, right? So in this case, the width is 2x and the height is 3 minus x squared. If you want, you can expand this out. You don't have to, but if we expand this out, we're going to get the area as a function of x is equal to 6x minus 2x cubed. Okay, so we want to maximize this area, right? We want to find the x such that the area is a maximum. So what we want to do is we want to plot this graph. So I'm going to plot the area as a function of x. And if you think about this, let me go back to this picture here. The smallest x could be is 0, right? And we know obviously it's not going to be 0 because then the area would be 0 of the rectangle. And the largest it could be would be this value right here, which is going to be basically the square root of 3, right? So this is like the square root of 3, 0. And then this point would be negative square root of 3, 0. So x can vary between 0 and the square root of 3. And we know it can't actually be the square root of 3 because then that rectangle wouldn't have no height, right? So it would have 0 area. So it's going to be somewhere in between those two values. Okay, so let's plot this function. I'll do that on the next page. Okay, so this is the graph of that cubic function, right? And we're only interested, we don't care when x is negative. Remember, this is x, and then this is the area, right? The y is the area. We don't care when, let me do that more neatly. So this is A. We don't care when x is negative, so we don't care anything left to the 0. And we only want to find the maximum area when x is between 0. And then this point right here, that is the point radical 3 comma 0, right? So that's radical 3. So that's the largest it can be in this particular example. So if you look at this, and I've even, if you just do this in Desmos and you click on the graph, it'll actually give you the relative maximum there, that peak point. And that point is 1 comma 4, right? So we're saying when x is 1, the area is 4. And that's the maximum that the area can be of that particular rectangle, right? It's saying when x is 1, then the area is 4, whatever it is, square units. So if we want to answer the question really wanted to know the width and the height. Well, remember the width was equal to 2 times x. So in this particular example, it'll be 2 times 1, right, which is 2. And then the height, well, that was the y, which was 3 minus x squared, right? That had the equation. So in this case, it would be 3 minus 1 squared, which is equal to also to 2 in this particular example. So it looks like the width is 2 and the height is 2. And that would be the answer to this particular question. Okay. Now, you guys may not have, it randomizes it. So you will probably get something different. But really the only thing that'll be different is this function right here, right? Instead of 3 minus x squared, you might have, 7 minus x squared or 6 minus x squared, whatever it may be. But the idea is exactly the same. It's the same exact plan that you want to do to solve this problem. Great. Hope that helps.